Hello everybody. My name is Kalle Happonen. I work for CSC. I've been working with OpenStack for a long time. I just realized I've actually been working for OpenStack over half my career. My first OpenStack summit was in Paris also 11 years ago. And we have been running OpenStack in production for quite a while. I'm here a bit of this to tell you what we have been doing for those 10 years. Before we jump into that, I think I should tell us a bit about we. So I work for CSC, and in Finland we're not very clever with naming, so IT Center for Science is our full name, and we do IT for science. So we have two sites in Finland, one in the capital region and one up in Kajaani in central Finland. In central Finland we have our big computers because there was an old paper mill that shut down, so there was a lot of power, a lot of cooling, a lot of space. So we moved our main data centers there. We are quite old, so we just had our 50th birthday a while back. We have had the first Finnish supercomputers. We brought internet to Finland, but those are still very strong in our DNA, like networking, national research networking and supercomputing. But nowadays we are about 600 people, so we do a lot of IT for research, education, memory organizations, libraries, and all of this. So basically, publicly available IT for research and education. So it's really hard to nowadays mention CSC without mentioning Lumi. Lumi is a supercomputer that's a big European project. When it came out a few years ago, when they actually launched it, it was the third fastest supercomputer in the world and the fastest in Europe. It's hosted in our data center in central Finland, in Kajaani. If you ever get to visit, the town is quite small, but the supercomputer is quite interesting. I do recommend you going in summer though, because it's much nicer. I'm not mentioning this mainly to brag about how big our computers are, although that is a bit nice also. But the main thing I mentioned, because we have very much HPC in very big tradition of high performance computing, and this also defines a bit how we run our cloud and why we run our cloud. So, speaking of which, clouds. We actually didn't start with OpenStack. For those of you who have been in research for a long time, you might remember in around 2010, about that time bioinformatics got really big. There was genetic methods got evolved, and the data much were big, and it's a relatively new computational science. So they didn't have the tradition of clusters and everything, and they had completely new data which was sensitive. So because we provide research infra, IT infra, they came to us and said hey, we need something for our biomed research. What can you do? After some discussion, I don't have the exact dates, it was around 2010. And actually, this would have been so much cooler to name this presentation 15 years of infrastructure, like clouds in CSC, because we would have wound up everybody. But around 2010, we launched a virtual private cloud based on OpenNebula. It was at that point 72 nodes of Westmere, something compute, and some storage. And it was quite popular. But also around the same time, in 2010, the cloud hype really started coming. There was the Amazons, and they started growing, and OpenStack started almost being a thing again. So it didn't take very long until we realized that actually the demand for cloud is much bigger than only bioinformatics. I wish I could say that we really knew what we were doing, but we knew that there was a demand for cloud. And we had some experience with OpenNebula. At that time, but the OpenStack started coming out, and OpenStack had a really big push behind it. The main reasons, I think we already had in that manner, in retrospectively the correct things. One of the main features I still love about OpenStack is the multi-tenancy. It was built in from the start. And when we started doing bioinformatics and other stuff and providing to different tenants, This is never meant to be like only for us, it's for researchers, so a lot of different users. So the multi-tenancy has been a very, very important part from the start. But also the APIs, the API first approach was very important for us because from the start we planned that we probably have to scale and we cannot scale with manual work. So it took a few years, but around 2012 we worked on our Pouta clouds. Like Pouta in Finnish means a rain-free day. Like it's probably cloudy but rain-free day. So, and production release was 2014, but running customer loads like before that. And then because we have all the code, we put much more effort on this side. We also moved our self-stable data cloud to OpenStack around 2015. We have done a lot of bad choices that haunt us. We are much smarter than we were back then. I'll come to some of those later, but if you want some horror stories, you can come and talk to me after this. Now, this is actually, I took a few weeks ago, I took actually this a screenshot of what I did from our production database. So on the top you see a select from shadow instances. So already deleted all the instances, but we still have the data. So the first ever virtual machine that was launched in our Pouta clouds. And there you see it's like in April 2013. I'm very happy that it wasn't me who named it VM, because I would have named it like QWERTY acid or something, but we had a very prescient admin who gave a good name to that. But this means we have carried that database since the start with us. So we have always upgraded, always provided a stable platform. And in the long term, I think like the stability of the platform is the reason it is as important as it is now for CSC. Because we don't generally like this user need to be able to trust our platform. And that said, I selected the oldest VM still running in our system. It's probably not, it's not on the same hardware, it's not behind the same switches anymore, it's not behind the same control plane servers anymore, it's like maybe not even in the same data center anymore, but it's still soon a 10-year-old VM that's running. And I think next summer I will bake it a cake and find out whose it is if it's still running, because I think it's quite fun to have like that history there. On purpose I didn't check what operating system is. I hope it's Ubuntu so you can actually update it so it's not an old CentOS 7 or 6. But so yeah, stability is very, very important for us, and it has been there. We have always done updates. Then I did a thing. I made a timeline of all our OpenStacks. This was really enlightening for me too, because when I looked at the dates, I really didn't realize like, oh, it's that long ago. But if you look at first the red dots, every red dot here is a new hardware integration. It might be a few servers. I think we usually don't do very small batches, but it might be a few servers, it might be 100 servers. But we do constant integrations. If I can count it correctly, there's 33 dots or something like here, which is an average 2.5 per year. So we almost always have some new hardware coming, some new hardware being replaced. The reasons why we do this is customer demand, growth, scaling, demand for new resource types, and with this long history, the application of old hardware, we need to replace hardware because we're going to run it indefinitely. So even though it is started a long time ago, it's by no means a stagnant cloud. It's actually like constantly being renewed and refreshed. On the bottom of the lines, you see some of the main, like big milestones. I think some of them are like, we were already under ISO 27K certification in 2015, and we have been there since. So that has been also, I think, a very big boon, because that has a bit demanded us to build a quality platform and considering things as we start. And especially with the new NIS2 regulations coming out, it's just like everything is so much easier to have already done it. Some other things like GPUs in 2017, Ceph-based object storage service in 2018, our OpenShift OKD service in 2019. And then around 2021 we passed like the 3000 VM limit or so. I think we're now about double of that. And our newest service that we have launched is Trove. So we have a database as a service for our customers for generic use, and that was launched about a year and a half ago. It is separate from actually it's separate OpenStack running on top of our OpenStack, just to do the maintenance domains, administration domains a bit different. But it has been quite a success. Then, if you look at the top of the line, this is the scarier part. It's where our OpenStack versions go. There's 2 releases a year, and if you see in the beginning, we were quite okay, we do 2 upgrades a year. This is going well. Then we started growing, and then with growth came growth pains. Suddenly, we were scaling a lot, doing a lot, growing, and then it's very hard to do that without increasing operations load, which means that our development load got much smaller and we had to do completely new things at scale. At the same time, because we were bigger, of course, there was more organizational interest. Hey, you need to do this properly, you need to do this properly, much more integration towards our organizational systems. So, and also taking care of completely user bases. So, from 2017 to 2022, basically, we barely did upgrades. It's not as bad as it looks, because you see that in many cases we just jumped many versions because we could back then easily. But still, it was quite a challenging time. Also, cloud was very popular, so we'll have some admin churn, and losing an admin with a very complex platform is quite expensive, so training new people takes time. But then we come to the bottom there, about just post-COVID. We have pretty much all of its life we have been a 5-person team, so it's on OpenStack itself. But then post-COVID, we finally got hey, actually this is getting important. We need new people, we need more people. So now we're a 7-person team. But that made all the difference, because all those 2 extra people go to development. So it takes time to train people up, but then you see how how it speeds up. Now we are at Rocky Stein train. This year we have 4 OpenStack upgrades going on. At the same time as we are having data center moves for both our clouds. So the things we can push through, it has completely changed, and now we are at a time where we can actually pay off all our technical debt and start looking into the future. This wouldn't be a presentation without some numbers. So as an engineer to other engineers, we always want some numbers. They are about the same size, our sensitive data side and our community cloud side. This is not on purpose. This is just how the growth has gone. I don't have the exact numbers, of course, and stuff, because as you see, it probably changes 2, 3, 4 times a year. So it is a bit hard to keep track. And we now have new big investments on both with the data center move, so it completely drastically changes again. But about that size. Also GPUs change. Hypervisors, we have around 700. I think that has been slowly growing, but about 700 hypervisor across these 2 things. So somewhat sizable, not as huge as some, but still a decent amount of work. And maybe the interesting thing here is the project amount. On the sensitive data side, it's still a lot of the computationally intensive sensitive data, because they still cannot run on clusters. So there are larger projects, but there are fewer of them. And even then we have some extra mandate, we have abstracted them away to a bit fewer projects. So there's about 70 projects, probably around 200 use cases we're doing that. But then the community cloud is used from anybody who needs it, and last I checked it was 1,700 projects. So something that really requires automation, and that is from both within CSC, within the Finnish Research and Education, and international. So it's a very, very wide use case base. So who are actually our users? If you would have asked me 10 years ago or so, what our user base is, it doesn't like, it would have changed a lot until now. So for the sensitive data, we still have a lot of research use cases. We still have like, I think we got a request of like, hey, we have a new genome set, we need to have like 300 terabytes of data, can we have it tomorrow? And this kind of stuff, so a lot of big bioinformatics research. But if you talk to researchers, OpenStack is quite a low-level service. And many researchers don't really like interacting with it, because I completely agree, it's not a bioinformatician's job to update kernels or do network parameters, they need to do their research. More and more on the sensitive data cluster, we are building higher level services for them. So the largest one we have now is a like virtual desktop. So researchers come and they just, instead of having to interact with the infrastructure cloud, setting up VMs and all those, they log into us and they say like, hey, I want to have a remote desktop over the web and with my sensitive data there, and then they get that, and that actually provisioned on top of our OpenStack, but they don't have to do all the technical work. And this has allowed us to reach like much more users, especially over the small use cases. On the community cloud side, it's like, we have a rule pretty much at CSC. If it can go on the cluster, it goes, or supercomputer, it goes on the cluster or supercomputer. Mainly because that is very efficient in resource use. Like, you can pack that full, it's harder to get more efficient than that. Anything that doesn't go there is it's basically on our clouds. So we do still do a heavy computation on the clouds. For example, we have big science use cases that need to run their own clusters, and they need to control their stack, they need a computing cluster somewhere, they're on our clouds. But more and more we have generic use cases for courses. We have some university courses that say like, hey, we have 200 students, everybody needs a VM. They come to us. We have internal production platforms, internal development platforms, and more higher level services for research on top of this. This is a picture I usually like to show. So usually I write on the x-axis I have how wide it is, like how widely applicable a service is, and on the y-axis how the abstraction level, how close to the user it is. So more and more we focus on, like, OpenStacks are underpinning most of this. And also our Ceph object storage is a very, very important part of this puzzle. But more and more we actually try to push users to higher level services that are on top of this, because they are better for resource use, they are less work for the users, and they get what they need more easily. This is just a small snapshot. There we have a lot more services, but from some of the super popular ones are like our OpenShift has already like 500 tenants or something. Our notebooks is used a lot for a lot of courses across Finland, and Tro was just, I don't know how many, some 100 databases there already, and it's a new service. So these are getting very, very popular, and we prefer it this way. So this now takes us a bit back to the why it's so important that our OpenStacks are stable and keep updated, because we have like 1,700 projects and like about 50 services running on top of it. Changing the OpenStack underneath will just it would be a major disruption for too many people. So our OpenStacks will probably become more and more hidden from end users because we push them to higher level platforms, but their importance will grow more and more because they will be the base layer for everything we do. Then I still have one more slide that is my most expensive lessons that I have done. The keen of you might have seen that we had, in 2014 we introduced Puppet for our automation, but we already own Puppet. Our current automation system is RDO and Puppet, because I have seen people run around and changing to, oh no, we need to use Ansible, Golla, or something else still. But for us, it has always been like, actually the tool is fine. It's like our process needs a lot of work to make sure that we can maintain this. And when our process is fine, like the automation tool doesn't matter much. We'll probably change away from Puppet at some point, but that is not where our admins spend their time tweaking and trying to figure stuff out. It's more when you do a data center move, we do like so much else that takes up your time. So generally I don't really care about tools, as long as the team is somewhat happy. Another thing that I think we all have been under is we often have pressure from people that this needs to happen now, we need to have this feature, we need to have this feature, we need to do this. And we have sometimes prioritized the short term. I very rarely prioritize the short term anymore. So this can be, some examples can be, if we want to launch a new OpenStack component, we are very careful that we know the operational impact of that before we launch it, because if we suddenly take half an admin away from the team, it's not like sustainable. Another thing that is very on the long term versus short term is hardware, especially in the infra business. If you do a bad hardware choice, you are usually locked in for 5 to 7 years, and that is a long time. So nowadays, when we do our hardware choices and other things, we usually try to have an exit plan and a maintenance plan before we even commit to buying anything. So when we have bought this, we already know how to get rid of this, because that can generate a lot of work in the medium to long term. And I'm glad I don't see very many Stack HPC people here, because I don't really care about performance anymore. It was a point of pride in CSC, like we are a high performance computing center, we need to make something performant. Up to a point, the easy optimizations, sure. We can be performant, but at some point, when you start tweaking the performance, where you lose is often maintainability. We have seen this, like in many times we try to tweak the LVM to be faster, so we get super fast disk access, and our NUMA adventures don't even ask about those. And all of that was paid in maintainability. And that has been very expensive, because then suddenly you put basically half an admin on this constantly, and that is a really expensive optimizations. So now if instead of optimizing 5%, we throw 5% more hardware at the 5% of the people who need it, and that's fine. It's not a big thing. If you have like really performance critical stuff, usually it's on the supercomputer. And then this is probably the last one. It's probably the biggest thing that almost had us. When we grew a lot, our operation work grew constantly. And operation work tends to scale with your scale, either amount of users, amount of hardware. So what that takes away is from development work. And as you see, like this is a constantly changing landscape. We have to react and we have to develop it non-stop. So when you take away the development work, you start to have problems. And that's why we are still on Wallaby when we should be on something like Caracal, but we're getting there, we're fine now. But for a long time, our operation work took way too much work, and that almost had us. It was so bad, when we got our new work, when we were like developing our work process all the time, I wrote a blog series about how we actually do our operations to make sure that we identify the issues and how we actually then react to them. And that, I think, was mostly it. And I think I have on time. I assume we have time for a few questions if you are.
I'm curious, you mentioned this desktop kind of service for the users, like to access. Are you developing it yourself, or are you using something like Open on Demand for it?
Like for our supercomputers, we have Open on Demand, but for our desktop service, we develop it in-house. I don't want to like take anything away from the developers, but there is tons of open source components you just glue together and then you basically build it into a service and maintain it.
I've seen from your schedule that you are still doing an upgrade path to get to the supported OpenStack versions.
Yeah.
Then once you are on par, how can I say, with the upstream supported version,
Yeah.
how will you manage the upgrade using the SL URP versions?
We'll do slurps. We'll put like the development time. We still have a lot of tons of stuff we need to fix, like moving away from Linux Bridge, providing IPv6 in our community cloud, and tons of other things. So, like we have enough work without it, so we'll minimize the work on the updates.
Thank you.
Okay.
What's the you mentioned that you have two stacks, so the sensitive and the community cloud. What's like the main difference between them? Is just the workloads that they actually serve, or they have like different deployment strategies?
They're quite close. We use mainly the same code to maintain them, but the sensitive data is much more locked down. Like the APIs are less accessible and more whitelisted. The network connections are always directly site to site, so it's basically a virtual private cloud more than a public cloud. So all the data that flows through is within the network control, the network domain of the user organization and stuff like this. So.
Thanks.
Sure. Thank you very much.